So we've got the region between 2x, the linear function here, and x squared, which is the parabolic function. And part A of this, which is the 2009 free response, is to find the area of that region. So to find the area of a region, all we have to do is take the upper function, subtract the lower function. And since we're doing it in terms of x, we'll integrate from 0 to x equals 2. So the upper function is the linear, the lower function is the parabolic. So we'll integrate 0 to 2x minus x squared dx. And like I said, each free response question is worth 9 total points. Sometimes they're broken up evenly, sometimes they're not. For this one, parts A, B, and C were all worth 3 points. So this right here is 1 point. If you had the right setup, that's 1 point. Then to get the second point, you needed to integrate it properly. So x squared minus x cubed over 3 from 0 to 2. And so if you did that, that's another point. And then lastly, you needed to evaluate that. So 4 minus 8/3 minus the 0 should be 12/3 minus 8/3 or 4/3. And so getting that was the third point. So part A was, I hope, pretty straightforward. Should be an easy 3 points there, yeah?
Yeah.
Could you do dy for this one?
You can. Do you want me to go through it that way or no? Or you just if you were allowed to?
Yeah, I just didn't know if I was allowed to.
Yeah, I mean, I wouldn't recommend it just because everything's already given to you in x and they gave you the intersection points, and just, upper minus lower should be easier. But if you wanted to, you could have, if that x equals y over 2, and then this would have been x equals root y, and you'd have done root y minus y over 2 from 0 to 4, and you still get 4/3. So when they put out their scoring guidelines, they usually just put out what's most commonly expected from students. So they would have expected you to do it in terms of x, but if you did it in terms of y, as long as you did it correctly, you'd still get all 3 points. They won't penalize you for that. And when they give the tests to the scorers, they say, okay, this is what we expect, but here are a bunch of other ways that kids could go about doing it to get the same answer. These are also fine. And then they'd go in and grade them. So as long as you still got 4/3, and like I said, I think it was what, root y minus y over 2 from 0 to 4 as your integral, you should be good.
Okay.
Any other questions there on part A? No? All right. Let's talk about part B. So part B says that the region R is now the base of a solid, and at each x, the cross section is perpendicular to the x-axis, has this weird area, sine of pi over 2x. So we're not given like a normal shape. It's not a square is the cross-sectional area or a triangle or something, but they give us the area formula. And so in order to find the entire volume of this solid, all we have to do is integrate the area formula across all of the x values. So we're just going to integrate sine of pi over 2 times x from 0 to 2. So for part B, you should have started out with the integral from 0 to 2, sine pi over 2x dx. And once again, just having that was worth a point. And then in order to integrate sine pi over 2x, you need to recognize that this needs a u substitution. And they don't normally write out the u substitutions, but if you choose to write out the u substitutions, that's fine. So I'll write it out just to make sure we're all doing okay with that. We'd let u equal pi over 2x, which would make du pi over 2 dx, which means we would need to add in a pi over 2 and a 2 over pi. And so we then end up with 2 over pi times the integral of sine u du And the pi over 2x would be multiplied by 0, right? With x equal to 0. Pi over 2 times 0 is 0, so our u value would be 0. And 2 times pi over 2 is pi, so our upper limit would become pi. Everybody good with that so far?
Yeah.
Okay. And then you should have gotten, when you integrate sine u, you get negative cosine u, so negative 2 over pi cosine u. And they would not require you to convert this back into terms of x, but if you did, that's fine. Just remember that if you convert it back into terms of x, you need to change these back to the original limits of 0 and 2. So second point would be for getting to here, or if you could have written, like I said, as negative 2 over pi times the cosine of pi over 2x from 0 to 2. Either of those would be fine. This over here is how they have it written in the scoring guidelines, but this would earn you the point as well. And then you just evaluate. So negative 2 over pi, and then cosine pi minus cosine of 0. Cosine of pi is negative 1, so we got negative 2 over pi times negative 1 minus cosine of 0, which is 1. So negative 2 times negative 2 over pi is 4 over pi. And there's your third point for that problem. Any questions on part B?
Do you have to show all your work for the U substitution, or can you just, like, I don't know, skip to the end where you get the answer?
Can you go from here to here? No. But if you go from here and don't write this any of this pi over 2 and 2 over pi, and just go straight from here to here, that's totally fine.
Okay, yeah, that's what I meant. Thank you.
Yeah, you can't just go from here to here. Because you'll note that, they give a point for this, for having the right setup. They give a point for having the right integral, and they give a point for this answer. And so if you don't write the actual integral out, if you don't write the original setup and you just go straight to here, you're not going to get that first point. If you just skip this and start evaluating, you're not going to get that point. So be as explicit as you can, but you never need to write the U substitutions if you can do them in your head. Which, for those of you that might be taking another semester of calculus someday, you want to be able to do these U substitutions in your head. So, any other questions on part B? All right, part C says we have another solid that has the same base, and the cross sections perpendicular to the y-axis are squares. So that was supposed to be perpendicular. There we go. There's my squares popping right out of this thing out of the page. And so what's the area of a square? Should be the side squared, right? So all we need to do is figure out what the length of one of these sides is. But since they're perpendicular to the y-axis, part C has to be done in terms of y. So it should be an integral from the lowest y value of 0 to the highest y value of 4. The side squared dy. And no points for getting that. What you need is the actual values of the side. So if we go back over here, the length of this side should be this x value minus this x value, right? The x value from the parabola minus the x value from the linear. So the x value from the linear is y over 2, and the x value from the parabola is root y. So we should have root y minus y over 2 squared. So we will have an integral from 0 to 4 of root y minus y over 2 squared dy. And They said you didn't need to bother to evaluate it, so that is your answer. You get 1 point for having the right limits of 0 to 4, not keeping them as 0 to 2 like the other problems in terms of x, and 2 points for having the right thing, root y minus y over 2 squared dy as your integrand. So this is 2 points. This is 1 point. Good or no? Any questions on part C or I guess any of it? How many of you got 9 out of 9? Anybody? Some of you? Hopefully some of you got 9 out of 9. All right. None of you are responding to me verbally or in the chat, so I have no idea. And if you are getting on average somewhere between like a 6 out of 9 or above on all of the free response, you're in really good shape to be getting yourself a very high 4 or a low 5 on the AP test, as long as you're able to do comparably well on the multiple choice. So the curving of it, the grading of it is fairly generous. So 6 out of 9 really puts you right between a 4 and a 5, if you can do that on all the free response and average 2/3 right on the multiple choice. So like I said, we'll talk more about how it's graded next week. All right, let's do another one. I find this one's fairly similar, but we do end up with a solid of revolution for this one for part C. So I will throw 15 minutes on the timer and I will let you guys work on this. Everybody good? Everybody ready? Oh, good, because your time starts now. All right, so first one is finding the area of the region. Again, this one is just an upper minus a lower. So our upper is root x and our lower is x over 2. So for part A, it should just be an integral of root x minus x over 2 dx, and our limits of integration go from 0 to 4. And so that was 1 point. Then we integrate that. Integral of root x is 2/3 x to the 3/2, and integral of x over 2 is x squared over 4 from 0 to 4. And evaluate at 4. This was your second point right here, getting this. And evaluating at 4 gives us square root of 4 is 2, cubed is 8, times 2/3 is 16/3, minus 4 minus 0 gives us 4/3, just like the last one. And that's your third point. Everybody good there with part A? Any questions on part A? So, say 1 point, 1 point, 1 point. Okay. Hopefully the area part's pretty easy. All right, so for part B, it then says that this region is the base of a solid and the cross sections perpendicular to the x-axis are once again squares. So easier. If we have squares in here, we know that the area of that square is the side length squared. And the side length should just be the distance from root x to x over 2. So that'll be root x minus x over 2. And we'll integrate that from 0 to 4 again. So it should be 0 to 4, root x minus x over 2 is the side length. We square it, dx. So this is part B. And having this is worth 1 point. And in order to integrate that, you would need to distribute it all out. So we end up with the integral from 0 to 4. Root x times root x itself is x. And then root x times x over 2 is x to the 3/2 over 2. And we have 2 of those as we go through it. So that's just x to the 3/2. And one of them was negative, so it's negative x to the 3/2. And then minus x over 2 times x over 2 should be positive x squared over 4 dx. And that's what we should be integrating. Is that what you all got to integrate there?
Yes.
Perfect. So x squared over 2 minus 2/5 x to the 5/2 plus x cubed over 12 from 0 to 4. So 1 point for that, 1 point for this. And then lastly, plugging them in to get your answer. Plugging in 4, you get 8 minus square root of 4 is 2 to the 5th is 32 times the 2 is 64/5. And then plus 64 over 12, which 64 over 12 could reduce and make life a little bit easier. What's that? That's 16/3, is that right? And so we'd have a common denominator of 15. You combine it all together, and I believe it came out to be 8 over 15. And that's your third point. Any questions on that one?
2 questions. 1, do we need to put units on the AP test?
So for these types of problems where they don't give you a specific unit, you do not need to necessarily write units squared or units cubed or anything like that. If you do, they're not going to take off points. If they give you units in the problem, like, oh, say that, you know, it's all measured in inches, then put inches squared or inches cubed. Generally, though, there is, they will not give you points for the units, either negatively or positively, unless it states in the question indicate units of measure. So, and none of the ones we'll see today will say that. Usually the area volume ones do not say that, but we will see plenty of questions that say indicate units of measure. And if that's that, if that's there, you are guaranteed that there is a point associated with the units. Sometimes only with the units, like just having the right units is worth a point, or sometimes the answer with the units, you have to have both to get the point. Does that answer your question?
Yes. Second question, is it okay if we like define the square on the side and then just integrate the square?
Define the square? Oh, you mean like,
or
like this?
You
like just write this
you
and
write
then,
like you write like a equals
Yeah.
x minus x square root of x. Yeah.
yeah, and then just write this integral, never writing this integral.
Yeah.
Yeah, that's fine. Yep. I mean, the people grading your tests are theoretically competent and will see what you're doing. Just be pretty explicit about what you write and what you do. Make it easy to follow, which for some of you is a struggle sometimes when I grade your quizzes. So try really hard to make it obvious what you're doing. Any other questions on part B? All right. So for part C, we're going to take this region and revolve it around the line y equals 2. And so if we revolve it around the line y equals 2, we are going to get cross sections that look like washers, right? And they're going to be a circle with a circle cut out from in between them. And so the outer radius should be the distance from 2 to the lower function, and the inner radius should be the distance from 2 to the upper function. So what is our outer radius? Should be 2 minus x over 2. So we'll write that here, r equals 2 minus x over 2. The inner radius ought to be 2 minus the other function. What was the other function? Root x, right? So 2 minus x over 2, 2 minus root x, and our integral should look like pi times the integral from, we were integrating from 0 to 4, right? Of our outer radius squared minus our inner radius squared dx. And for this one, there are again 3 points associated with it. 1 point is for having the right constant and the limits out in front, and 2 points for having the appropriate integral inside. Any questions on part C? Let's see, could I have done this using cylinders? Let's see here, looking back at the problem. Yeah, you definitely could have done it using cylinders. So if we had chosen to do it using cylinders, that means that you would have to do it in terms of y. We draw the rectangle like that. It would have a thickness of dy and be going around like this. And our radius here for the cylinder would be 2 units minus y, however high we've gone up. And our height would be the right function, which would be x equals y over 2, minus the left function, which would be x equals y squared. So if we'd done it using cylinders, you'd have had 2 pi times the integral from 0 to 2 of 2 minus y times y over 2 minus y squared dy. And that answer won't show up in their scoring guide, but if you were to write that as your answer, you would get full points for that. Does that make sense? Good with that? Is that what you got when did you do it with cylinders?
Yeah, but it would be x equals 2y, right? Not x equals y over 2.
Yeah, yeah. I could learn to divide properly or multiply properly. Maybe one would think I should be able to multiply. Yeah, you're right. 2y, but yeah. Yep. So that would be fine. That answer would give you full credit. The garbage that I wrote where I didn't divide properly would have given me 1 point for having the right constant and things out there. I would have caught that though if I was taking the AP test. Hopefully. But yeah, welcome to use cylinders. Just it won't ever be in the scoring guidelines and it won't ever be required. So. Everybody good there? Okay. We don't have time to go through the last one that I wanted to do today, but I'll put it up and I'm going to give you guys the last 10 minutes or so to work on it and finish it up afterwards if you don't finish it before class is over. And then before we take the quiz tomorrow, we'll go through this one and then any other last second questions you might have, and then we'll take the quiz. So here is the last one. Please don't leave. Please spend the next 10 minutes working on this. And if you have questions as you're going through it, you're welcome to ask, but otherwise we will go through the whole thing tomorrow. Ready, go.